and welcome to the third presentation of Bringing STEM to Light. This is Module 1, and this activity is focused on the classroom cave. So in the last presentation, we looked at the persistent misunderstanding about how light allows us to see, affectionately known as laser eyes. So now we know that nothing is emitted from our eyes and able to let us see. But how do we see? This presentation, we're going to take a dive into an activity that is really, really effective for disrupting that misunderstanding and also inviting students to kind of uncover and create for themselves a new understanding of this familiar phenomenon known as vision. The activity introduces two big ideas and a couple of different science process skills. At the end of the activity, students will understand that it's light from a source, not their eyes, that is required in order to see. And they'll go through a process of predicting, testing, changing a variable, and testing again so that they can make a conclusion and develop a model of how we see. So we'll start with an opening activity that sets kids up for the main event. And you'll want to start by darkening the room as much as possible and ask students to complete a task. I like to ask them to begin describing for me how is it that we see. You can invite them to use words or pictures and just kind of create a model. Show me how it is that we see. Create an explanation. And if the room is dark enough, which hopefully it will be, before too long, kids will notice that it's really hard to see, and they'll start to complain and generally raise objections about the fact that they can't complete their task. And it's at that point that you can have a discussion about why is it so difficult to complete your task when there's no light. Well, it becomes pretty obvious pretty quickly that it's hard to see when the lights are off, and when it's hard to see, it's hard to do anything. Now you can turn the lights on and have just a short brainstorming session with the kids. Ask them to generate a list for you of dark places. Where do they experience darkness? They experience darkness maybe if they were to go into a cave at nighttime, or maybe in a movie theater. Just have them generate a list. And when it looks like they're about done, you can kind of help them conclude, right? Well, why is it dark? Why is it dark in those places? Well, because there's no light. And they may or may not come up with the word source, but really it's because there's no light source. There's nothing providing light for the space. And once that's complete, you can allow them time, now that the lights are on, to finish their attempt at explaining how it is that we see. And so, remember, this is a really persistent misunderstanding, right? So even though we've just kind of had a very brief conversation about the fact that, when it's dark you can't see, some of them still may have misconceptions about exactly how it is that we do see. So we're going to take them through yet another activity, and this one is a little bit more involved. The first step is to build a cave. And in this case, what we mean by a cave is a very, very dark space. Someplace that's big enough for one or two students to go inside and actually experience the total darkness. You can spend some time either building the cave as a classroom. That's kind of a fun classroom activity that you can do, or you can have groups of 4 or 5 students each build their own cave. And if you're really crunched for time, or you don't have the materials to build a cave, you can use a dark closet or any space basically where it's going to be very dark. The next step is to prepare and hide some paper dolls. And again, you can either do this in advance and have the dolls all hidden when the kids come into the room, or you can get them involved. You can have a classroom activity of actually cutting out the dolls. But what you're going to end up with is 3 sets of 2 dolls each. And you're going to have 2 dolls that are made of white construction paper, 2 dolls that are made of black or very dark blue construction paper, and 2 dolls that are made out of aluminum foil. And you're going to hide one set of the dolls inside the cave. If you have more than one cave, then each cave should have all 3 dolls inside the cave. And you can hide the dolls either by placing them on the floor or stick them to the wall, or maybe even stick them to the top or the ceiling of the cave if it's small enough to do that. But you want them in there, and you want them to be affixed somewhere where they won't be moving around. Okay, so now that the dolls are made and hidden inside the cave, we're going to move to the next part of the activity. And here we will show the kids either as a classroom or individually or in small groups. We'll show the kids the 3 dolls, and we'll invite them to make a prediction. And we're going to want them to predict, which of these dolls do you think you would be able to find inside that dark cave? And you remind them, there's no light in there, it's very dark. Which of these dolls do you think you're going to find? A lot of students believe that they're going to be able to find the white doll, and even more will say that they can see or find the foil doll. Lots of them will tell you they won't be able to find the black doll. And that shows you that they've got a little bit of an intuitive sense about the relative brightness of things, the ways that light reflects off of things. But at this point, we just want to get them to predict what they think is going to happen. And once everybody's made a prediction and that prediction has been recorded, you can send the kids into the cave in 1s or 2s, again, making sure to close it up and make it very, very dark, and have them go in and actually look, see if they can find the dolls. And when they come out, record what happens. They won't be able to find the dolls because it's completely dark. Some of them will be completely surprised by this. And once everybody has tested their prediction and we've got all of the results recorded, you can have a conversation with them. Why is it that they couldn't find their dolls? And they'll answer you, it was dark. And then you can ask, well, what could you do to find the dolls? What would you need in order to find the dolls? And they'll tell you a flashlight, probably. What they need is a light source. So gather some flashlights, and in the same groups that they went in and looked in the dark, send them in with a flashlight and let them have the experience of being able to shine the light through the dark to find their dolls. And then record those results or ask them to present their results to the class or to a small group. Now, before you introduce them to the modern theory of vision, before you actually present them with this explanation, ask them one more time to create a drawing or to use words to explain how it is that we see things. So here it is. Light from a source bounces off an object and into your eyes. That's it. Now, obviously, there's a lot more going on with vision once the light gets into your eyes, and a lot more going on with the light. But that's the basic theory of vision that Al-Hazen worked out in 1011 in his Book of Optics that was not understood for centuries and centuries before that, even though a lot of people thought about it. And if you think about it, it's pretty impressive, because when you're looking around the room, literally all you're ever seeing is light. That's it. It's light from a source bouncing off an object and into your eyes, where your brain can perceive it and give it a name and tell you what it is. It's pretty amazing. So this foundational activity actually accomplishes a couple things in addition to upsetting that misconception and introducing the correction. It gives students in the class a common experience, and it goes a long ways towards ensuring that everybody's kind of starting off on the same page. Everybody's starting off with a common experience that you can build off of as you move forward in exploring more about the phenomenon of light and really how it behaves. But before we get into how light behaves, I want to give you some background as the educator, a little bit of background in the science of light, and give us a chance to answer the question, what is light? And that's what we're going to do in the next presentation. So I'll see you there.